Now we are going to see associative property. Now in this associative property, first of all we'll take three integers a plus b plus c is equals to a plus b plus c. Now in this I'll place a bracket on a plus b, and then in this side I'll place a bracket on b plus c. Now we'll verify that whether it is valid for addition, subtraction, multiplication and division. We'll check that and we'll write the conditions and we'll note it down, those conditions. Now first of all, for addition I'll directly give you the examples. Okay, additions, if I take 6 plus 3 plus 2, what I'm going to get? I'll be getting 6 plus 3 9 and 9 plus 2 is 11. Same way, if I take the different order, what I'm going to get? You'll see here 6, 3 plus 2 is 5, and this will be 6 plus 5 is equals to 11. So in the case of addition, associative property do exist. Now in subtraction, we will verify that. It means in place of addition we are going to change the sign, that is minus over here. Now we'll take same number 6 minus 3 minus 2. So we'll take order 6 minus 3, that is 3, 3 minus 2 is 1. And now I'll change the different brackets over here. Now what I'm going to get, I'll see here 6 minus 1, that is equals to 5. So in subtraction, this associative property is not applicable. Now next is multiplication. So what I'm going to do here, in this multiplication, I'll change the sign into multiplication. So 6 into 3 into 2. So first 2 I'll keep in bracket. So 6 into 3 is 18. 18 multiplied by 2 is 36. Same way I'll take the same number but the order will be different. Now this one will be 6 multiplied by 6, that is 36. So here you can see that left hand side and right hand side of this property is equal in the case of multiplication. Now we are going to see for the case of division. Now in the case of division, again we are going to replace the sign by division. 6 divided by 3 divided by 2. Now if you see here 3, here it will be 2, 2 divided by 2 will be 1. Now we'll change the bracket over here. So we are not going to get the same answer because 6 divided 3 by 2 will be 1.5 and here it will be 4. So in division, associative property is not applicable. So associative property, it is applicable for addition and multiplication. Next we are going to see, now this is distributive property, a bracket b plus c. We know that how to remove the bracket. A multiplied by b, that is eb. A multiplied by c, that is ac. So what we'll do, this is what can be applicable for the case of addition and subtraction. So you can take in this way the following examples and you can substitute and you can identify in this. Next topic is additive inverse. So additive inverse means what? In this, whatever the number or a rational number is given to you, we will change its sign. So for example, a rational number p by q is given and we want to find its additive inverse. So what we'll do, what is the sign over here? Plus. So now the answer will be minus. For example, if it is minus a by b, then your answer will be plus a by b. So additive inverse, only you have to change its sign. Next is multiplicative inverse. In this multiplicative inverse, we will do reciprocal. You might be knowing about reciprocal. What is reciprocal? If I say A by B, multiplicative inverse will be B by A. For example, a number, let us take 2 by 3. So the multiplicative inverse will be 3 by 2. Now we are going to see to represent a rational numbers on number line. How we can represent? We know that if I take a rational number 2 by 3, so how we can going to substitute this in a number line? So we'll first of all draw a number line, we'll mark it down, and we'll identify that this 2 by 3 number is lying in between which two numbers. So we'll divide it. If I divide 2 by 3, I'll be getting 0.666. It means it is lying in between 0 to 1. So 0 to 1. Now in this rational numbers, what is the denominator? Denominator is 3. So we'll try to make 3 parts over here. 1, 2, 3. Okay. So in these 3 parts, so how we are going to write this position, this number over here? So this is the first part. So we are going to write 1 upon 3. This is the second part. We are going to write 2 upon 3. Sorry. Here it will be 1 upon 3. Here it will be 2 upon 3. And here it will be 3 upon 3. And 3 upon 3 is equals to 1. So now we have to represent 2 by 3.